Hello dear students, I am Chaman Kumar. I welcome you all to this physics class. Today we are about to start our electricity chapter, which is your first chapter of your syllabus. Okay, this chapter is very important from examination point of view as this chapter carries 16 marks, means both electrostatics and current electricity. Together they are carrying 16 marks. So this chapter is very important from examination point of view. All right. So before we get into the electricity chapter, we have to know its historical background, how it started. All right. So the history goes back to 1600 BC. All right. What happened? A substance called amber was found in the sea beaches of Greek. All right. Remember the name? It is called amber. All right. And it is a gum-like substance like this. And this is in this picture. You can see that. Okay. This is called your amber, and it is used for making some jewelries like this. Okay, ring. And what is important about this substance is it is seen to attract some feather pieces, dust particles, and pieces of leaves. Okay, and this attracting property was later attributed to charge. Okay, the reason was found out that it is because of the charge on that amber that it could attract these things: feathers, dust particles, and pieces of leaves. And most importantly, the Greek name of amber is called electron. All right, and from this electron word, electric field, electricity, electric potential, all these words have been derived. That is why this amber is very important. And what is its importance? The importance is its attracting property, and this attracting property is because of the charge developed in this body. Okay, now we'll see what is electricity. Okay, as you can see in the slide, electricity is the study of charge. It is called the study of charge. All right, what is charge and all that we'll be discussing in the next slide. For the time being, remember that it is the study of charge. When I say study of charge, there are two possibilities. A charge can be at rest or a charge can be in motion. So if we'll study the properties of charge while it is at rest, then this branch of physics is called electrostatics. And when the charge is in motion, this branch of physics is called current electricity. Charge at rest is called electrostatics, and charge in motion is called current electricity. Next, we'll see what is charge. All right. Well, before charge, the definition of electrostatics comes. Okay, you can see that there are two words in this, in this single word, electro and statics. Electro stands for electron, and statics means at rest. All right. So from this, name, we can know that charge is at rest. It is the branch of physics that deals with the force, field, and potentials due to a charge at rest. All it says is the properties of charge while it is at rest. All right. We'll be discussing detail about force, field, and potential. These three words now seems to be a bit difficult, but later on we will study all that. But for the time being, the definition is it is the branch of physics that deals with the field, force, and potential due to a charge at rest. Now the question comes, what is a charge? All right. Generally, charge comes from an atom. All right. And an atom, there are three particles. In an atom, there are three particles. Electrons are outside the nucleus, and neutrons and protons are inside the nucleus. An atom is generally a neutral entity. All right. Neutral means it is chargeless, it is not ionized. All right. In an atom, there are equal numbers of electrons and protons. Okay. और हमें पता है कि इलेक्ट्रॉन का चार्ज जितना होता है, प्रोटॉन का भी चार्ज उतना ही होता है, बट साइन अलग होते हैं. तो जितना इलेक्ट्रॉन्स रहेगा, अगर उतना ही प्रोटॉन्स हमारे पास है, तो हमें बॉडी न्यूट्रल मिलेगा. नाउ थिंक ऑफ द सिचुएशन, अगर वही बॉडी में से मैं कुछ इलेक्ट्रॉन निकाल दूंगा, तब क्या हो जाएगा, बॉडी में पॉजिटिव चार्ज बढ़ जाएगा. मतलब प्रोटॉन नंबर इलेक्ट्रॉन नंबर से ज़्यादा हो गया, तो बॉडी अभी पॉजिटिव बन जाएगा. As you can see in this diagram, all right, here is a model of an atom. Inside the nucleus there are neutrons and protons, and outside the nucleus there are electrons. And if there are equal number of electrons and protons, the body will be neutral. Generally an atom is neutral. So the definition of charge goes like this: it is the intrinsic property of a body that is responsible for its electrical properties. Okay, it's the intrinsic property of the body which is responsible for its electrical properties. Electrical property means the attracting and repulsing, how whether it will attract or repel another body, that depends on the kind of charge it possesses. Next. Okay guys, next we will see how we can produce charge. All right, in the last slide we saw that a charge means the difference in the number of electrons and protons. All right, so how we can develop that? There are three methods. All right, we can develop charge by friction, by conduction, or by induction. So in friction means generally rubbing. Okay, if we'll rub two bodies together, what will happen? Electrons being outside the nucleus, they are quite loosely bound. All right, and they are supposed to come out of the atom, and this is what exactly happens when we rub two bodies. Electron from one body will be transferred to the other body. All right, and the body that loses electron becomes positively charged, and the body that gains electron becomes negatively charged. All right, and some examples I have given here. All right, when a glass rod rubbed with silk or wool, it's seen to attract some paper or fur pieces. Okay, generally paper and fur pieces are neutral, but still they are attracted by a charged body. All right, similarly, this example you can try also. Okay, a balloon rubbed with air can attract small paper pieces. All right, and one more thing to observe here, that if I will take two glass rods and both will be rubbed with either wool or silk. All right, now if I'll bring these two rubbed uh, glass rods together, okay, if I'll bring them closer, they will repel each other. And why will they do so? Because they are equally charged. They are, they have same kind of charge. It may be positive or negative. All right, as they have same charge, that is why they will repel each other. Now take two glass rods or plastic rod, whatever. All right, suppose one you will rub with wool, another you will rub with silk, and if the rods are brought together, then they will attract each other. Why it happened? Because now they have different charges. All right, so here we have some observations or conclusions, that if we have similar charges, like charges, they will repel each other. If we have unlike charges, they will attract each other. All right, and the most important thing here is to understand that which particle is responsible for your charge. It is electron, not neutron, not proton, because they are inside the nucleus, they are tightly bound to the nucleus, and they cannot come out of the atom. That is why they do not take part in charge production. Only electron is responsible for charge production. This is what in this slide. Now we will see what are the different types of charges. Okay, electron is a negatively charged particle, proton is a positively charged particle, neutron has no charge. That means neutron is not charged. Okay, when a body loses electron, it becomes positively charged. When a body gains electron, it becomes negatively charged. When equal numbers of electrons and protons are there, then the body is neutral, as we have already understood this. Now, there is one more method of charge production. It is called induction method, and it is very important. Why it is important? See here how in this method of charge production we can develop an opposite charge. All right, see this diagram. Or what happens in this process is we need not bring these bodies in physical contact, just they will be at some distance, still there will be charge production. This is what the speciality of this method. All right, in the first figure you can see that there's a plastic rod which is negatively charged, and we have got a sphere which we want to charge, okay, which is initially neutral, equal number of positive and negative charges. Now see in the figure 2, we have brought this rod to, we have brought this rod near the sphere. All right, when we did this, what happened? These electrons of the sphere, all right, got repelled by the electrons of this rod, and they come to the opposite side of the sphere, and this side of the sphere becomes positively charged. Okay, so what happened when we brought this rod here? Okay, then what happened? There is a polarization. Polarization means there is a separation of positive and negative charges. Right, now see in the figure 3 what happened. In order to produce charge, what we have to do, we have to ground this sphere. Okay, this sphere is grounded here. This is the symbol of grounding. Now what will happen, this electrons that are accumulated in the opposite side of the sphere, they will rush into the ground. वो सब ग्राउंड को चले जाएंगे, तो अभी हमें क्या मिलेगा, एक completely positively charged sphere. That, so what happened here, initially the plastic rod was negative, but what kind of charge we have developed here, positive charge. So here an opposite charge develops. So from the induction method of charging, we can produce an opposite charge. Now this is the last method of charge production. It is called charging by conduction. Charging by conduction. So what happens here? Here we have to bring these bodies in physical contact. When they will be close together, they will be in contact with each other. Then there will be a transfer of charge. Here you can see in this diagram. Suppose I want to make this body charged. All right, I want to charge this body. All right, so this is initially neutral. Now what I have done is I have brought a negatively charged rod and kept it in contact with the sphere. So what happened, the excess electrons in this rod transferred to the sphere, and the sphere got negatively charged. Here we have got a charged sphere which was initially neutral. So this is how, so what kind of charge here we could develop? The rod had initially negative charge, and the sphere is also negatively charged. So what happens is, in conduction method of charge production, we have got the same charge. The same charge can be developed here. So in this video, we saw that the history of the charge, how it produced, its different branches and different methods of production. All right. So in friction method, there are transfer of electrons, one body to another body. That is why there is charge production. And in induction method, what happens? We just bring the two bodies closer to each other. We need not keep them in physical contact. Still, there will be charge production. And in conduction method of charge production, we have to bring two bodies in physical contact, and the same charge will be developed in both the bodies. So this is all about in this class. We will be back with another video, and we will see the nature and properties of charge in the next video. Thank you.